All right. Problem solving in data, lesson 1 is all about percentage problems. These are things you've learned in junior high that some are easy to approach, some are tough. It's how much you really understand percentages. So let's take a look. This is standard number 2, which is solve single and multi-step problems involving measurement quantities. Now remember, percent is basically a fraction out of 100. Okay, anytime we compute with percentages, we always change the percent to a decimal when computing in a problem. And to do that, you either take the percent and divide it by 100 or move the decimal 2 places to the left. So if I had like 26.8%, I could either do 26.8 divided by 100, which would give me 0.268, or I could just take 26.8, move it 2 places to the left to get 0.268. If I have a whole number like, say, 6%, that decimal is right here. When I move it to the left, it becomes 0.06. Now, when you're talking percentages, know and understand a majority of the time, they should add up to 100. So if I have like a discount of 40% discount, if I want to figure out what percent I'm paying for it, 100 minus 40 gives me I'm paying 60% of the original price. So the discount and the percent you're paying should add up to 100. Now, percent increase. Anytime you're talking about percent increase or decrease, you take the amount of increase or decrease, right, and divide it by the original amount. I don't know why these got cut off. Okay, so keep that in mind. Let's go through some examples, and hopefully you can apply them to some other problems. So a book was on sale 40% off its original price. If the sale price of the book was $18, so you paid $18 for it on sale, what was the original price of the book? Now think about this logically when you look at the answers. If you paid $18 for the original book, right, or for the sale price of the book, that means it had to be more than $18, which means A and B don't make sense. Okay? Now, there's 2 ways to approach this problem. One is knowing percents. If it was 40% off, that means I paid 60% of the original price. So how do I write 60% as a decimal? 0.60 or 0.6 times, did I know the original price? No. But 60% of, meaning multiply, of the original price was equal to $18. So if I divide both of these by 0.6, it would tell me the original price, 18 divided by 0.6, would give me $30. Okay, so the original price was $30. Now the other quick way to do this is just know that these answers represent the original price and calculate what you paid for them, all right, or the sale price. So if I do 7.2 times 0.60, right, 7.2 times 0.6, is that going to give me 18? No. But when I get down here and I multiply this by 0.6, 30 times 0.6 gives me 18. Therefore, I know $30, right, with 40% off gave me $18. Some of you guys might also calculate, do 30 times 0.4, and that would give you 12, and then take and subtract the $12, which would be 18. Either way, you could use these answers to find the sale price that matches up with 18. Next one. In 2015, the population of city X and city Y were equal. So you know in 2015, X was equal to Y. The population of city X increased by 20%. So X went up 20%. And the population of Y went down 10%. All right. If the population of city X was 120,000 in 2010, so in 2010, X equaled 120,000. What was the population of city Y? Well, you know they were equal. This is the year 2015. And you know in 2015, right, it says from 2010 to 2015, X increased 20%, Y decreased 10%. So what we have to do, it says, what was the population of Y in 2010? Well, X was 120,000 in 2010. So what I'm going to do is figure out what was the population of X in 2015. So what we're going to do is we're going to take 120,000 and add the 20%. There's two ways you can do this. The first way is to take 120,000 and multiply it by 1 plus 0.20, which would be 120,000 times 1.2, which would give you 144,000. The other way to calculate the population in 2015 is to take 0.2, multiply it by 120,000. That would give you 24,000, and then do your 120,000 plus 24,000, which would give you 144,000. So no matter what, the population of X in 2015 was 144,000. Now remember, that's when X was equal to Y. And remember, right, that Y went down 10%. So now, if Y went down, if Y decreases 10%, right, from 2010 to 2015, what we're trying to find is which one of these, right, if we take 10% off, would give us 144,000. Well, you know A and B don't make sense. Now remember, if it decreased 10%, that means it held 90% of its value or population. Okay, so what I'm going to basically do is say 0.9 times what would give me 140,000 or 144,000. So if I go to my calculator and I do 0.9 times 160,000, what does that give me? 144,000, which is exactly what I'm looking for. So letter C. In State X, Mr. Camp's 8th grade class consisting of 26 students was surveyed. 34.6%, right, reported, right, that they had at least 2 siblings. The average 8th grade class size is 26, right? If the students in Mr. Camp's class are representative of students in the state's 8th grade classes, and there are 1,800 8th grade classes in the state, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? Now, what you have to understand here is there are 1,800 8th grade classes, not students. Okay? So the first thing we're going to figure out is how many students are in the state. Well, if there are 1,800 classes and there's an average of 26 in each class, if I multiply this together, right, that means there are roughly 46,800 students in the state. Now, it wants to know the best estimate of the number of 8th grade students in the state who have fewer than 2 siblings. So at least means 2 or more. So there's 2 ways to do this, right? One thing I could do is figure out how many students have 2 or more by doing 34.6%, which would be 0.346 times, right, 46,800. That would give me 16,192. Now that's how many have 2 or more. Now I'm going to subtract that from 46,800, right? And that tells me there's about 30,600 that do not, or that have fewer, right, than that. So basically I took 46,800 times 0.346. That gave me 16,607 roughly. That's how many had 2 or more. So now if I take the 46,800, subtract that, that tells me that about 30,600 had less than 2. Now here's what I do, is I said if 34.6% have more than 2, what percent has less than 2? Well, 100 minus 34.6. So 100 minus 34.6 would give me 65.4. So 65.4% have fewer than 2. So what is 0.654 times 46,800? That would give you approximately 30,600, letter C. It's 2 ways to approach that problem. Here, the Townsend Realty Group invested in 5 different properties listed in the table above. The table shows that the amount in dollars the company paid for each property and the corresponding monthly rental price in dollars the company charges for the property at each of the following locations. Townsend Realty purchased Glenview Street property, right? So we're looking at Glenview, purchase price, and received a 40% discount off the original price. So 40% off of the original price, along with a 20% additional, okay, for purchasing a property in cash. What is the best approximate of the original price in dollars of the Glenview property? Right away, you know that they paid $140,000, right, after all the discounts for that property. Now, here's the thing. If it was 40% off the original price, what percent, right, did you actually pay? If it's 40% off, right, you paid 60%, right, of the original property. Okay, so right away, what I would do is take 60% of the original, and then if you got another 20%, right, so that gives you the sale price. Then if it was another 20% off, that means you paid 80% or 0.8 of the sale price. So what I would do is just come over to each of these answers, right? And the first thing I'm going to do is I'm going to find the sale price by multiplying by 0.6. And then I'm going to find the final price by doing 0.8 times the sale. Because if it was 20% off, that means I paid 80%. So real quick here, 0.6 times 350,000 gives me 210,000 times, now I'm going to take 210, multiply it by 0.8, gives me 168,000. It should be 140. That doesn't work. So next, 291,700 times 0.6 gives me 175,020. Now I'm going to multiply that by 0.8, and right away gives me 140,016, which means the original price was close to 291,700. Okay, next one. The atomic mass or weight of an unknown element in atomic mass units is approximately 20% less than that of calcium. The atomic weight of calcium is 40 AMU. Which of the following best approximates the atomic weight in AMU of the unknown element? So there's two ways to do this one. If it's 20% less, that means it's 80%, right, of calcium. So if I just do 0.80 times 40, right, 0.8 times 40 would give me 32. Okay, now another way to do it is to figure out what 20% of 40 is. And if you do 0.2 times 40, you would get 8. So that means it's 8 AMUs less. So we would just take 40, subtract the 8 to get 32. Two ways to approach that problem. All right. Nick surveyed a random sample of freshmen, of his high school to determine whether the fall festival should be held in October or November. Of the 90 students surveyed, 25% preferred October. Based on this information about how many students in the entire 225-person class would be expected to prefer having the fall festival in October. Well, what percent preferred October? 25.6%. So what is 25.6% of 225? Well, 0.256 times 225 would give me 57.6. So roughly 60 people. All right. And then the last one. The bar graph above shows renewable energy consumption in quadrillions of British thermal units in the United States by energy source for several energy sources in the years 2000 to 2010. Of the following, which best approximates the percent decrease in consumption of wood power in the United States from 2000 to 2010? So you got to remember the dark bars represent 2000, the light bars represent 2010. So if I'm looking at wood, right, this is the column I'm looking at. So in 2000, right, you had 2.25. In 2010, you went down to 2. Remember, what was the percent decrease, right, for this? Well, the amount of decrease, right, would be you started with 2.25, you went down to 2, so the amount of decrease would be 0.25. You went down to 0.25. Over, what was your original amount? 2.25. So what I'm going to do is take 0.25 divided by 2.25, and that tells you it went down about, let's pull out the calculator. So 0.25 divided by 2.25, and you would get a 0.11. So it would be about 0.111, which is about 11%, which is letter B.